Here is an example that illustrates the use of the list of lists structure in APPL, and it is flip a fair coin twice and let X be the number of heads, find the CDF capital F of X, and also find the 81st percentile of the distribution of X. Now the APPL code in this case contains just 3 statements. The first one sets the random variable X equal to, you can see you have 3 sublists here, so the list of 3 lists, and the first part here contains 1/4, 1/2, and 1/4. Those are the 3 mass values associated with 0, 1, and 2 heads. The second sublist contains 0, 1, and 2, and that's the support of the random variable X, because you can only get 0, 1, or 2 heads when you flip a fair coin twice. And finally, the third sublist has 2 different things in it. The first one in double quotes will be the word discrete, and it has to be a capital D, and that will tell you that you have a discrete random variable as opposed to a continuous random variable. And when you see PDF here, even though you would think that would mean probability density function, because you have a discrete random variable here, this really means that you are looking at a probability mass function defined on the first and second sublists. So that establishes the random variable X. Then what we want is the cumulative distribution function of X, and that's simply done by typing in CDF of X. And to find that 81st percentile, you can also type in IDF with X as a first argument and then 0.81 as a second argument. When you type those in, it will give you the CDF of X as a step function that is 0 for X less than 0. Then at 0, it jumps up to 1/4. At 1, it jumps up by 1/2 to 3/4. And at 2, it jumps up the additional 1/4 to make it up to 1. And that is your step function for a CDF. If in addition you want the 81st percentile, that will be returned as X sub 0.81 is equal to 2.